It started with a question, one that no one had really asked out loud before. Why do some people have blue eyes? Not how. Science had a decent grip on that. But why? Why do these dazzling shades of sapphire sky and steel even exist in the first place? The man asking this question was Dr. Hans Eyberg, a Danish geneticist at the University of Copenhagen. At the time, he had no idea that his curiosity would unravel one of the most fascinating twists in human evolution. A twist that started with a single genetic mistake thousands of years ago. A mistake that gave rise to every blue eye on Earth. Dr. Eyberg wasn't hunting for blue eyes specifically. He was part of a larger project studying the human genome, particularly the OCA2 gene, which is known to influence pigmentation in the skin, hair, and eyes. But one day, while analyzing the DNA of people with blue eyes, he noticed something strange. They all had one particular mutation in a gene neighboring OCA2 called HERC2, a tiny change, a single letter in the 3 billion letter long book that is human DNA. This was no ordinary mutation. It wasn't just a quirk that popped up now and then. Every single person with blue eyes, whether they were from Scandinavia, the Middle East, or North Africa, had the exact same mutation. That meant one thing: every blue-eyed person alive today shares a common ancestor. Rewind time, say around 6,000 to 1,000 years ago. Somewhere near the Black Sea, a child is born. Nothing extraordinary about the birth at first glance. But deep inside that child's DNA, a single change has occurred. One that shuts down a specific pigment switch. More specifically, this mutation affects how much melanin is produced in the iris, the colored part of your eye. Less melanin means lighter eyes, in this case blue. But here's the kicker. Unlike other eye colors, which can vary widely in tone and saturation depending on other genes, all blue eyes have essentially the same amount of melanin. Blue eyes aren't really blue at all. Blue eyes are like the sky or the ocean. They only appear blue. There's no blue pigment in a blue eye. Instead, the structure of the iris scatters light in a way that reflects back blue wavelengths, similar to the way sunlight scatters in the atmosphere. It's called the Tyndall effect, and it's why blue eyes can look so vivid and why their appearance can change depending on the light. But why did this mutation stick around? There are a few theories. One is the classic sexual selection argument. As early humans migrated north into Europe and sunlight became more scarce, lighter features might have stood out in a mostly brown-eyed world. Maybe blue eyes were seen as exotic, rare, or beautiful. And perhaps that beauty translated into more mates and more blue-eyed babies. Another theory says it's part of a broader set of evolutionary adaptations. Lighter skin, lighter eyes, and lighter hair all emerged around the same time, possibly to help humans absorb more vitamin D in areas with low sunlight. But these are theories. What we do know is this: the mutation didn't spread randomly. It moved like a ripple through ancient populations. And over the millennia, it left behind a genetic fingerprint, a trail of blue eyes across Europe, the Middle East, and eventually the world. Today, only about 8 to 10% of the world's population has blue eyes. And yet, every one of those eyes can trace their ancestry back to that one ancient individual. That means, statistically speaking, if you have blue eyes, you're related to every other blue-eyed person on the planet. Distant cousins, tied together by a twist in the code. A mutation that could have vanished, but didn't. In biology, mutations often sound like bad things, errors, flaws, but they're also how evolution works. They're how we change, how life adapts, how beauty emerges in the most unexpected ways. Blue eyes are a mutation, but one that caught the eye of history. A genetic accident that became an emblem of curiosity, beauty, and mystery. They're a reminder that deep within us are stories written over thousands of years. Some are in our memories, others are in our genes. And sometimes, all it takes is a glance, a spark of color, to realize you're part of something ancient, something shared. So next time you look into a pair of blue eyes, whether your own or someone else's, remember you're staring into a living fossil, a shimmering relic of a moment long past, a genetic whisper from a single child born near the Black Sea, who never knew the mark they left on humanity. A child whose eyes were the first to turn blue. If you found this helpful, hit that like button, subscribe for more amazing content.